now going to focus on exponents and square roots. The first one, section 1.7, will cover exponents. Well, what are exponents? The basic dictionary definition is meaning or referring to something that is at a high standard, lifting it up high. And so regarding to math, this is in which the number is raised higher. If you look at the example, the 3 is raised up. It's usually a smaller called a superscript, and that is the exponent. So this quantity that's represented by the greater power basically is identified by this little raised base number. So 2 to the third power is not saying 2 times 3. This is saying that we have it 3 times. So the 2 to the third power is going to be 2 times 2 times 2. Okay? So it's not 2 times 3. So 2 times 2 times 2 equals 8. Here we have 3 to the fourth power. Okay? The 4 is the exponent. It's the raised number. This is going to be 3, okay? A total of 4 times. Not 3 times 4, okay? But 3 times 3 times 3 times 3. So I do 3 times 3, which is 9, 9 times 3, which is 27, and then 27 times 3, which is 81. Okay, so the 3 is the base number, 4 is the exponent. The 3 multiplied 4 times would be the repeated factors, and 81 is actually the simplified form, which is called the answer. This is the simplified form. And so we call that exponent to whatever number that is, power. So this is to the fourth power. Now a number squared is going to be the name given to a number that is to the second power. So instead of saying 4 to the second power, or to the 2 power, it's going to be 4 squared. And this is 4 times 4. There's 2 4s there. So when we write it exponentially, the exponent form is 4, okay? And then you have the 2 exponent. If we read it, it's 4 to the second power, or 4 squared. If I want to write the expanded form, that's going to be the 4 times 4. And then simplified, as I just said, that's the answer. So if a textbook or a worksheet says, please give me the simplified form, that's really all they're asking for is simplify it or give me the answer, give me the end product here. Now a number cubed is going to be the exponent of 3. So squared is the exponent of 2. Cubed is the exponent of 3. So 6 cubed would be 6 to the third power. So this is 6 times 6 times 6. So 6 times 6 is 36, times 6 is 216. Okay, so we have the words here that we've kind of seen before about the word form or the red form, the expanded form, and then the simplified or the answer form. Okay, so if I go 1 to the fifth power, it's going to be 1 times 1 times 1 times 1 times 1. And of course, the simplified or the answer is 1. Now, any number that has an exponent of 1 gives us the same number. Okay, so it's just saying, okay, 3, can't multiply it by another 3, it's just 3 by itself. 27 to the exponent of 1. To the 1 power, that would just be 27. 865 by itself to the 1 power is just 865. Okay, so if we want to write the exponential form, 5 squared would be 5 with the superscript 2, and that's going to be 5 times 5. If I want the simplified form, okay, it would be 25. 9 cubed would be 9 with a 3 superscript. 6 times 6 times 6 would be 6 with a 4 superscript. And then number 4, 3 times 3 times 3 times 3 times 3 would be a 3 with a 5 superscript. So let's take a look at that. 5 squared, 5 with a 2. 9 cubed, 9 with a 3. Okay, 6 with a 4. and then 3 with a 5. Okay, 5 superscript, fifth power. So how would you read it? Okay, 5 squared, 9 cubed, 6 to the 4th power, 3 to the 5th power. Okay, and what would be the simplified answers? 5 times 5 is 25. 9 times 9 is 729. Remember, it's not 9 times 3. I was even tempted to say that. It's 9 times 9 times 9. And then this is not 6 times 4. This is 6 times 6 times 6 times 6. Okay? And then the simplified form for 3 to the 5th power is 243. Okay, write the expanded and simplified form. Remember, expanded meaning, okay, if we have 3 to the 4th power, you're going to write 3 times 3 times 3 times 3. The simplified is just the answer. Okay, and that gives me 81. Okay, what's the exponent? Okay, if we have 2 to what power equals 32? Okay, in order to get to 32, I have to multiply the 2 5 times. So that would be the superscript or the exponent of 5, okay, to the 5th power. Now, natural numbers. Natural numbers are the counting numbers. Okay, these are basic whole numbers. Now, a natural number is raised to the 0 power equals 1. So if the exponent is 0, it automatically makes it 1. So 8 to the exponent of 0 would be 1. 42 to the exponent of 0, okay, or to the 0 power would be 1. 342 to the 0 power would be 1. Now, if I raise a 0 to a number, 0 3 times, always be 0. 0 7 times, okay, would be a 0. Okay, because 0 times 0 times 0, 0 3 times, still gives me 0. Now, if I want to go ahead and make this the expanded form, we've already done this. Our first couple little sections there. I want to divide this up into parts. I'm actually going to use my exponents. So instead of saying 4 billion, that would be my word form. But if I want to do an expanded form in exponential notation using exponents, I can say, instead of 4 billion, I can say 4 times 10 to the 9th power. So 10th to the 9th power would give me billion. So 4 times a billion is 4 billion. 2 times 10 to the 8th power, 10 to the 8th power would give me 200 million. Now let's move into square roots. Now, if you can understand what a exponent is, like 5 squared equals 25, this is kind of like the opposite. It's kind of like the square root is kind of like dividing when if something is squared, it's kind of like multiplying. That kind of opposite mentality. Okay. Now it's not exactly that, but it's in that same vein. So square root of 25 would be what times what. It has to be two of the same numbers equals 25. One number times itself equals 25, and that's 5. So the square root of 25 would be 5. So if I have 5 squared equals 25, if I go the opposite direction, the square root of 25 would give me 5. So let's look at the definition. A square root is one of a number's two equal factors. So 5 times 5 equals 25. I'm going to choose one of those because they're equal, they're the same number, and that number is going to be the square root of 25. Okay, now let's take a look at that symbol. It looks kind of like a division symbol, but it's not. So if I put a 25 inside that little square root symbol, the answer will be 5 because it has to be two numbers that are exactly the same equaling the number under the square root. So if 25 is under the square root, The answer is 5. So 5 times 5 equals the square root of 25. Okay, so the inverse or opposite operation, okay, for squaring a number is called taking the square root. So this is exactly what I was just saying. It's kind of the opposite of being squared. Okay, the opposite of being squared. So if I have 5 squared, gives me 25. Let's do the opposite of that. I would take that 25, go the other direction, so the square root of 25 would be 5. So squaring a whole number results in a number known as a perfect square. Let's look at some visuals to help you. If we know that 7 times 7 equals 49, okay? If 7 and 7, two of the same numbers, okay, that's the expanded form for 7 squared, which is the exponential form. So 7 squared equals 49. So what do you think the square root of 49 is going to be? Well, we just kind of go backwards. Okay, so we know 7 times 7 is 49. So the square root of 49 has to be the same two numbers. It would be 7. What number squared equals 1? Now we know 1 times 1 equals 1. So the square root of 1 is 1. What about 4? We know 2 times 2 equals 4. So that would be 2 squared equals 4. So what would be the square root of 4? 2. So if you understand square root, that kind of comes from that idea of, or the opposite of the squared. Okay, 13 squared, that's 13 times 13. So 13 times 13 would be 169. 14 times 14 would be 196. 15 times 15 would be 225. If I'm able to understand the squared, I can now go ahead and do the square root. Okay, so square root of 25 would be 5 times 5. But what about the square root of 169? In order to figure that out, I have to find two numbers that are exactly the same. If I multiply them together, will give me 169, and that will be 13. So 13 times 13 is 169. What about 81? Blank times blank has to be the same number, equals 81. 9 times 9 equals 81. So the square root of 81 is 9. I'm going to use my information that I know about square roots and squared, my exponents, to kind of figure this out when we have large numbers. Okay, very large perfect squares. So if it has a perfect square, kind of like 81, the perfect square has, in order for it to be a square root, it has to have the same two numbers that are exactly the same. If I go ahead and do the square root of 81, that's going to be 9. But if I add zeros to that 81, let's say I have a very, very large number. Let's say someone says, okay, give me the square root of 810,000. Well, I look at that and I'm like, whoa, that's a huge number. Well, no, let's break it down and make it simplified or simple. If I look at that, I look at 810,000, and inside that I see 81, and I know the square root of 81 is 9. Well, all I have to do is do the square root of 81 and find out 9. Now I look at those numbers there. 810,000 has 4 zeros. The square root of that will be half of the number of zeros. So 81 is 9, and then the half of 4 zeros would be 2 zeros. Okay, so let's try and make this hopefully make sense here. Let's look at the practice number 1, 400. Okay, I don't even have to worry about 400. Let me just do the square root of 4. Square root of 4 is 2, because I know 2 times 2 equals 4, so the square root of 2. Now let me go ahead and add the zeros to the 2. But I can't just add 2 zeros there. Whenever I do a square root, it's going to be half the number of zeros. So that square root is actually going to be 20. Okay, because half of 2 zeros would be 1 0. Let's take a look at number 2. The square root of 25 is 5. The half of those zeros, there's 4 zeros, would be 2 zeros. So it would be 500. Okay, let's find the square root of 400. So I'm going to find the square root of 4. And then I'm going to look at, I have 2 zeros there. So I'm going to find half of the number of zeros. That's only 1 0. So square root of 4 is 2. I add half of the number of zeros. That's 1 0. So that would give me 20. Okay, there we go. Okay, let's look at 250,000. Let's just focus on the 25. Ignore the zeros for right now. Square root of 25 is 5, so 5 times 5. And then the half number of zeros would be, instead of 4, we'd have 2. So square root of 25 is 5. I add 2 zeros to the end of that, 500. Okay, what about square root of 1,000? Let's make it easier. Okay, square root of 1 is 1. Okay, 1 times 1 equals 1. And then half the number of zeros of those 6 would be 3 zeros. So I'm going to add those 3 zeros to the end of 1. That would make it 1,000. Okay. Okay, if you have any questions, please reach out to me. Send me email or Marco Polo if you need me to explain any of these further. And we'll do some practice on Monday. But please do some of the practice questions to help you today as well.